Algebra 2, we're looking at 11.4 on probability. We're asked to determine a sample space and outcomes. So a sample space is actually all possibilities of what could happen. And I'll just say all possible outcomes that you could have for a certain event. So let's look at this number 1, part A. A bag has 8 balls labeled A, B, C, D, E, F, G, and H. You can see right here we've got 1, 2, 3, 4, 5, 6, 7, 8 different balls here. And one ball will be randomly picked and its letter will be recorded as the outcome. So for part A right here, or for the very first part, they want you to, or I should say for part 1 maybe, give the sample space. They're saying what could possibly happen. So in Alex, you're going to have this parenthesis. Well, one of the balls that could be selected would be an A. You could also get a B, a C, a D, an E, an F, a G, or an H. And you'd have all of those. Each one of those would be a possibility. Of course, such a letter as Z, that would not be part of the sample space. That's not a possible outcome. But then we want to give all outcomes for a very specific event, choosing a letter from A to D. And we're always going to be separating these with commas, by the way, when you're typing them into Alex. If you're saying only from A to D, that would be an A, a B, a C, or a D, nothing else. It's just A up to D. So eventually we're going to be looking at probability. So probability is always going to deal with the total number of outcomes, the total number of possibilities, and then whatever event that we'd like to have happen, we could call that a success. We'd want to know how many ways we could get a success. So let's take a look at part B. It says a number cube has faces from 1 to 6, and we want to find the sample space. So we've got 1, 2, 3, 4, a 5, or a 6. That would be all possible outcomes that you could get rolling a dice. But then they want you to list the event of rolling a number less than 5, smaller than 5. Well, you could get a 1, 2, 3, or a 4. 5 itself won't even count. So that's really all you're doing. It's not going to take you too long. But then, as we go to the back page, you can see we're actually going to go to probability. Probability is going to be a fraction, and it's going to be the total number possible, that's your sample space, and the number of successes that you'd like to have. So whatever you want to have happen, you're measuring it. So it says a bag contains balls labeled 1 through 9, and one ball is randomly picked. Well, you know that you're going to have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your sample space, right? That's your sample space. You don't have to write that down. But I hope you know that that means there are 9 possible outcomes you could have. How about a multiple of 3? You could get 3 times 1, which is a 3. You could get 3 times 2, which would be a 6. Or you could get 3 times 3, which is a 9, out of that sample space. So you can see there are 3 of these. There are 3 different ways you could get a multiple of 3. So this is your probability, 3 over 9, but we have to reduce it. If we were to divide the top and the bottom by 3, you would get 1/3. As we're looking at our final problem here, we've got a bag that contains 8 tiles, and we've got letters A, B, C, D, E, F, G, and H. One tile is randomly picked. So we can see that we've got 1, 2, 3, 4, 5, 6, 7, 8 total. We've got 8 total down here. There are 8 possible outcomes. But what's the probability of picking a vowel? Well, a vowel from that list would be A, and the only other vowel would be E. So that's 2. So remember, we're trying to build a fraction of the number of successes, whatever we're trying to measure, out of the number possible. And 2 out of 8 you can reduce, and you'll get 1/4. And that is it for this lesson.